Hi guys, welcome to this page of the notes. Again, what we're doing is we're taking a look at that first objective where we are solving rational equations. And the way that we're solving rational equations is by finding the LCM of the denominators, and then we multiply everybody, multiply each term by that LCM so that the denominators will cancel out, leaving you with a new equation that doesn't have any fractions in it. That'll allow you to isolate the variable and solve. So let's go ahead and do a couple more of these just to see how they go. Again, we need an LCM, so let's go ahead and find it. First, 6. I'll need to factor 6, which of course is 2 times 3. I'll need to factor, well, a 2, but 2 is, so it'll just be a 2. And then x minus 6, well, that quantity is just going to be x minus 6. So my LCM, now that I've got everybody factored, is going to be each factor of the greatest number of times it appears, which of course would be the exponent. 2 shows up twice, but I only need to keep it once. They're both to the first power, so we'll just keep that one. 3 only shows up once, so I'll keep it. 2 times 3. The x minus 6 only shows up once, so just keep the x minus 6. And I wind up with an LCM of 6x minus 6. All right, so there's my LCM, 6x minus 6. I'm going to multiply this by each term in the original rational equation. Again, there's a number of steps I showed you on the previous page that we can skip. So I'm just going to jump straight to, I'll multiply this guy by x times x minus 6, multiply this guy by x, and so here's what it's going to look like. 6 times x minus 6 multiplied by 5 6 plus 6 times x minus 6 multiplied by 2 over x minus 6 is equal to 1/2 multiplied by 6 times x minus 6. All right, so again, I'm squeezing, but again, I just jumped straight to the part where algebra says whatever you do to one person, do to everybody. So I'm just multiplying every term originally in the problem. 5, 6 multiplied by my LCM. 2 over x minus 6 multiplied by the LCM. Now what happens is the fractions are going to go away, right? So I have a 6 and a 6. Those drop out. It leaves me with 5 times x minus 6. Fantastic. I have an x minus 6 and an x minus 6. Those drop out, and it's going to leave me with 6 times 2, which is 12. And then on the other side, they don't completely go away, but the 2 will cancel with the 6 and leave you with a 3 instead. So on this side, I would have 1 times 3, which of course is just a 3, multiplied by the quantity x minus 6. So 3 times x minus 6. I got some distributing to do. I wind up with 5x minus 30 plus 12 is equal to 3x minus 18. Okay, let's see here. I will subtract the 3x to the other side. That's going to leave me with 2x. What did I do here? If I went third, yeah, so that's going to leave me with minus. All right, so negative 30 plus 12 leaves me with a negative 18. And then I still have the negative 18 on the other side. That is really interesting. Look at that. I'll add 18 to the other side, but negative 18 plus 18 just drops out. You're actually left with 2x is equal to 0. Divide the 2 to the other side and you get x is equal to 0. X is equal to 0. All right, well, we got to check that guy because remember, extraneous solutions are certainly possible. So if I were to plug in a 0, I'd wind up with a negative 6. So what you wind up with is 5/6 minus, right, because that's a negative, so it would be 5/6 minus 2/6, right? Well, I already have a common denominator, so it's 5 minus 2, which is 3. 3/6, and 3/6 will reduce to 1/2. I get 1/2 is equal to 1/2, and so yes, the answer checks out. It's actually a solution. It does solve my rational equation. All right, hey, I got another one for you right down here. I think we're getting the hang of these. Let's see how this one goes. All right, my LCM. Well, 12. 12, of course, is 4 times 3, but 4 is a 2 squared. So it'll be a 2 squared times 3. 48, that one's a little trickier, but I think if you think about it for a second, 48 is 16 times 3. Now, there's other ways to get to 48, so why would I do 16 times 3? The reason I would do 16 times 3 is because 16 is 2 to the 4th power. So 2 to the 4th, which is 16, times 3, which I already have a 3, gets me to 48. And then, of course, my other one is x minus 4, but that quantity is just its own factor, x minus 4. So my LCM, well, I keep each factor the greatest number of times it appears. 2 squared, 2 to the 4th. I keep the 2 to the 4th. Keep either one of the 3's, doesn't matter which one, and of course my other factor. So I have 2 to the 4th, which is 16, times 3, times x minus 4, we wind up with 48, x minus 4. Again, what we're going to do, skip a couple of steps here because I think you're getting the hang of it. This guy, this LCM, needs to be multiplied by everybody in my original rational equation. So again, I'm going to have to squeeze a little bit here, but here's what I would get. I would get 48 Nope. Okay, on the other side, okay, great. So there we go. I've now obeyed all the rules that we have in algebra where I've multiplied everybody by the same thing, so we're all happy. Everybody got Skittles. Yay. Now we just go ahead and cancel, right? Real easy, x minus 4 and x minus 4. So those drop out. 48 and 48 drop out. The 12 and the 48 is going to reduce to, I believe, a 3, right? Yeah. 48 divided by 12, yes, right, 48 divided by 3, sorry, 48 divided by 12, yeah, 4, so 4, so I have 4, and then, actually though, no, you know what, here, let me write it this way, this is what I was doing. 48 divided by 12 leaves you with 4, so that 48 reduces to a 4, there we go. Okay, so now we're back on track. Here's what I've got. I wind up with 4 times 7, which is 28. Then I've got that quantity, x minus 4. And then I'm left here with a negative 48 times 9, which I believe comes out to be, is it 432? Minus 432. Again, let me double check my calculator, but I think that's right. 48, negative 48 times 9. Yeah, minus 432. And then on the other side, the 48's canceled, so I would have 55 times x minus 4. All right, awesome, we're doing good. Okay, so let's distribute. We got some distributing to do here before we go too much further. Okay, so that leaves me with 28x. 28 times the negative 4 is going to be a minus 112 minus the 432 that was already there, 55x. And then 55 times the negative 4 is going to be a minus 220. I will subtract the 28x to the other side. So let's see here. All right, well, here, let's do this. So I have 28x. The negative 112 and the minus 432 is negative 544. Okay, and then what I'll do is add the 220 to the other side, subtract the 28. So I have minus 544 plus 220 is equal to 55x minus 28. And so here's what we wind up with. I wind up with negative 324 is equal to 27x. Go ahead, do that division. And I get a minus 12. So negative 324 divided by 27 is a minus 12. Again, you've got to check that, just plug that negative 12 into the original expression and it will check out for you. So again, now we've done 3 of these problems. The idea is this: find the LCM. Once you've found the LCM, you'll multiply that original rational equation, multiply everybody by the LCM. It'll allow you to cancel those denominators, so you wind up with a new equation that doesn't have any denominators in it, right? That'll allow you to isolate the variable, right? Get that variable on the same side, combine your like terms, and then just get that x by itself. Once you've found x, please check your solutions. We'll see here in just a second, and a little bit on another page of the notes, we'll try a couple of these where you wind up with a solution that doesn't work out. It is possible to get an extraneous solution. So I got a few more example problems for you. Head on over to the next page of the notes. I'll meet you guys there.